Okay, so now we will talk about changing velocity in one dimension. So if your velocity is changing, which tells you directly that the slope of distance versus time graph is changing. So in that case, it means your distance versus time graph is curved. It has curvature. So basically, to understand and gather information about your velocity by looking at distance versus time graph, you need to consider how is that curvature is changing, how is the slope on that graph is changing. So I just drew two tangential lines on this graph that I gave you like this. This is the graph itself for distance versus time for motion. So number one and number two is basically 2 points that if you can calculate the slope at those moments in time, it would give you instantaneous velocity of this motion at those two instants, right? So what you do here is that we don't do the real calculations since it needs some derivatives, and we don't do calculus space physics at this level. What we do is that look at the tendency of how the slope is, whether increasing, decreasing, is it positive, is it negative? So by looking at that, we can draw how the velocity versus time graph would look like. That's what I'm going to do. But before I start doing that, I just want to show you how you basically compare the slope of these 2 points I gave you. So number one and number two, I would say corresponds something like this, right? The line one and line two. So if you look at these pictures, you can carry them over here in the XY coordinate system. First of all, the angle is always is the angle with the line, the tangential line you draw here to find the slope, and the positive x-axis. So the angle needs to be 0 to 90 degrees for the slope to be positive. So whenever you draw these tangential lines on these distance versus time graphs that occurred, you look at the angle that the line that you're drawing is making with the positive x-axis, okay? So for both of these lines, you actually have an angle which is less than 90 degree. 90 means like up to here, right? This is 90 degree between x and y. They're perpendicular to each other. So if the angle is smaller than 90 degree, the angle between the tangential line and the positive x-axis is less than 90 degree, it tells you that these slopes are positive, okay? If the angle is less than 90 degree, then the slope is positive. So if you had a different kind of curvature, something like this, for example, take, if I can draw a tangential line, this one, if you draw like x-axis over here, you can see the positive x-axis falls onto this line. And so the angle of this tangential line and the positive x-axis is greater than 90 degree, right? This line, if you carry it here in this xy coordinate system, is something like this, which means that from the positive x-axis, you go find the line. This is greater than 90 degree, right? 90 degree ends at y-axis, so this angle is greater than 90 degree. So if your angle is greater than 90 degree, then it gives you basically slope to be negative. Okay, so if your angle is like this or like this, both is positive. 2 has a bigger slope than 1 because 2, look, the angle is bigger than 1, right? So if the angle is bigger, the slope is bigger. The number that you associate with it is bigger. So the basically slope for number 2 is bigger than number 1. Both is positive, okay? So in time, when you look at this graph, you can safely say that the velocity for this object is increasing in time, and this object is moving in positive direction, okay? Whereas if you take a point here and take a tangential line to here, you can see this is actually getting closer to the x-axis. It's not as steep as this one here, right? So for the negative angles, for the negative slopes, again, as much as the line that you have is close to the y-axis, close to this vertical axis, its slope is going to be numerically going to be bigger. And therefore, in this case, if you call this 1 and this 2, then in time, your slope is increasing because it's getting steeper. Again, it's getting closer to the vertical axis. If you compare these two, this one has a smaller, 1 has a smaller slope than 2. 2 is a bigger slope. Therefore, in time, if this was the time axis, basically, you can safely say that in this motion, the object is moving in negative direction, and its velocity is increasing because the slope is increasing as it goes. Here, for example, if you draw a line, it's even more steeper than number 2, right? So you can say here the velocity is increasing in the negative direction as time goes on. So hopefully this makes sense. So when you look at this graph, you hopefully understand when I talk that basically number 1 is the region from 0 to 20. Number 2 is the region from 20 to 40. And number 3 is from 40 to 60. And 60 and the further in time is standing for region 4. So in number 1, the curve is something like this. So if you look at number 1 curvature, this curvature is not steeper than this, right? This is steeper. It's getting steeper. If you look at the lines that I drew before, the slope for this later one is bigger than this one. Both is positive because the angles they make with the positive x-axis is smaller than 90, so both is positive. And the slope is increasing because the line that you draw for the slope is getting steeper, getting closer to the vertical axis. So in time, in this first region in this motion, the velocity is increasing in the positive direction. So that's why I drew from 0 to 20. Velocity is increasing in the positive direction. And it reaches to some value. To calculate that, you just need to do derivatives, as I said, so we don't do the numerical calculation, but we can draw what the velocity versus time graph looks like. In the second region, the curvature is something like this. And so you look at the first and the second slope tangents that I draw here. It is closer to the x-axis than the previous one. So which tells you from here to here, from the first region to second region, the slope is getting smaller. And if you compare this with this one here, it's even getting more smaller. And even at 40 seconds exactly, it is exactly 0, right? Like, look at this. This is basically parallel to the x-axis, and therefore the slope for this point is 0. So basically from the first region to second region, during the second region, the slope is still positive, but it's getting smaller, 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 and it reaches to 0 at 40 mark. So it is still positive value for velocity. It gets smaller, 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 and reaches to 0. That's why I drew this second part of the graph for the velocity versus time. So I'm gonna number them, like this is the first one here. This is the second part of the motion. Now I'm gonna show you how to draw the third part. So in third part, you see, yeah, that's right. So the third part, you have the tangential line here, and then it goes steeper, right? If you look at these two lines that I'm drawing, you would see the slope is getting bigger, but it's negative. You can see that these lines with the x-axis, they're making bigger than 90-degree angles, like I showed you here, right? So you can also kind of, I guess, keep that in mind that whenever you look at a line like this or this, they're positive, okay? Line like this or this is negative slope. These two are positive, these two are negative. This one, the first one, has a bigger slope than the second one. In this one, the first one has a smaller angle, so it's not steeper. The second one is steeper, so the slope in the second one is bigger. Okay, both of this is here. These two are positive slopes. These two here are negative slopes. Here, 2 has a bigger slope than 1. Here, 2 has a smaller than 1 slope. Okay, so your line, as it gets steeper, meaning that it's getting closer to the vertical line, this vertical line, it's closer to the vertical line, its slope is bigger. That's why you need to remember to be able to compare. So in the number 3 here, what you look at it, the angles are negative, but it's getting bigger, it's getting closer to the y-axis, so it's getting steeper. Therefore, the slope is bigger later in time within the third region. So after it reaches the 0 at 40 seconds, it basically starts to increase its velocity in the negative direction. So that's why I draw this graph, because as you know, upward is a positive y values and downward is negative y values, right? Below the origin, the values where the y-axis is negative values. So here you have a velocity after 40 seconds up to 60 seconds is increasing in negative direction, which is basically upward direction, right? So after 60 seconds, which is here, so you still have a negative slope, as you can see, still negative slope, but it's getting smaller and smaller, even at some point later that I don't have the scale to show. I don't know where it's going to be cutting the x-axis, but it's going to reach to a point where its slope is 0 again, just like here on top at 40 seconds, and just like at 0 point, it also has a 0 slope. That's why I started my velocity value from 0, and it increased in the positive sense, decreased during region number 2, reached the 0.0 velocity again at 40 seconds, and then increased in the negative direction, and then started to decrease in the negative direction, and then at some point after 70 seconds, I don't know when, but it's going to reach the 0 again. So this is how you basically draw a graph of velocity versus time when you have a changing velocity. So you can show it like this graphically. I did skip the giving you scale on the velocity because I don't know, I didn't do the calculations, so I can't give you the values for the velocity because I can't calculate the slopes without using derivatives. Therefore, I just kept it out. But visually, you can basically create what a velocity versus time graph looks like from a changing velocity motion in one dimension. I hope this helped for your changing velocity motion understanding. Have a good day.